Hi Cooper 6, Mr. Turner, Mr. Grayson here. We're going to be doing the Ski Jump Challenge Lab today. All right, make sure you have your copy of the Ski Jump Challenge Lab. Put it in Notability so that you can take some data with us and answer the questions at the end. Once you're done answering those questions, send it back to Schoology and submit it so that I can see your work. Okay? We're going to start by reading the introduction, and then Grayson's going to talk to you about the materials. Let's go. Introduction. Have you ever watched an Olympic athlete perform a ski jump? As the skier began his or her run higher on the ramp, why were they going faster at the bottom? All the energy for the run and the velocity down the hill comes from potential energy gained by being lifted up to the top of the hill, and then the conversion of that potential energy into kinetic energy during the run. Athletes try to build up as much speed as possible while maintaining control before they fly off the end of the jump. We're only going to use 3 pieces of tubing from our roller coaster ALU, you and your group, or just Mr. Grayson and I, all right, will construct a mini ski jump, which will propel a marble into a cup. The challenge? How far can you get your marble to travel through the air and successfully land in the cup? Okay, now it's time for materials. Grayson, our first material is the tubing. Where's the tubing? Excellent, sir. The next one, we don't have a meter stick, but we do have a measuring tape. Grayson, where's our measuring tape? Show everybody. Very good. We also need masking tape. Here's our masking tape. And finally, a marble. Marble? Cool. The material list also says a stand, but we're going to be using our wall over here in our playroom. So, we'll be right back with the procedure. Thanks. Okay, Cooper 6, we're going to get started on the procedure. Step 1, find the mass of your marble using the triple beam balance. We're at home, we don't have a triple beam balance, but I did Google a marble, and your average marble is about 6 grams, and so it says here, change that mass to kilograms. So we are now looking at 0.006 kilograms, okay? And that's going to be the same mass of the same marble for the whole lab. So write that down in all of those boxes on this side, okay? Next, it says construct a ski jump with 1 loop using the tubing. We did that. We're good. Next, make sure that the tape holding the loop does not interfere with the track. Check. Next, it says use a small pieces of masking tape, fasten one end of the ski jump to the stand. Well, we fastened it to the wall, so we're good to go. Use a small piece of tape, mark the starting position at the upper end of the track. We did. I marked it. It is 1.5 meters, okay? 150 centimeters, or 1.5 meters, okay? Good. Using trial and error, determine the height in meters of the starting position needed to keep the marble in the track, complete the loop, and land in the cup the furthest distance possible from our table. So we have our cup down here. You can see it on the floor. We're going to try to get the marble into the cup from the tubing. Okay. It says you may not climb on anything, but I'm going to let Grayson stand on his chair. Okay, we can't cut the ramp, but we have 2 pieces of tubing, so we're good to go. Can't hold the ramp, don't worry, it's taped to the wall. And we have 4 chances to try to get it in the cup, but we can make changes each time. So we're going to do our very first trial now. Taking a look at our data table here. All right, trial number 1. Don't forget to put 1 there. The height is 1.5 meters. The mass of the marble, again, is 0.006 kilograms. And we're ready. Mr. Grayson? Hold it where the tape is. Let it go. Oh, not so good. We'll be right back with trial number 2. Number 6, we're back. Just so we have a recap of trial 1. Trial 1 was 1.5 meters up in the air. The marble is always 0.006 kilograms. We were not successful. The marble was too short. So Grayson suggested that we move the cup closer. Okay, our very first time doing this, we set the cup 1 meter away. So now we've moved it closer for trial number 2, and we're going to give it our best shot now. Ready, Grayson? Okay, up at the line. Go. Oh, that happens.
You have to stop that thing.
Grab it. Good.
You have to stop it.
Yeah, that's okay. Go. Oh, almost. Be right back. We're back, everybody. Trial 2 was not successful. And what happened was the marble fell just to the left of the cup. The cup was far enough, and the marble made it that far, but it was just a bit to the left. So Grayson suggested that we move the cup to the left. Okay, so now we're going to do trial 3. We moved our cup. Grayson's going to go ahead and go stand on the chair. All right, let it go. Oh, almost. Be right back. Okay, this is it, folks. We are on trial number 4 now. Trial number 3 was a no again. Again, no change in the height, no change in the mass of the marble. It was not successful. The marble fell to the right of the cup. Seems like we're trying to just find the right spot here. So Grayson suggested we move the cup a little bit to the right. Okay, we're going to get started now with trial 4. Let's go. Ready? I hope it makes it. That's all right. Yes, go. Here we go. Oh, almost. Be right back. Cooper 6. We had a no-go on that 4th trial. So, I know it's not on the data table, and we're not going to take any data, but we did move it a little bit closer, and now we're going to give it one final shot. All right, Grayson? Go. Folks, so after that celebration from, I'm assuming you saw the marble go into the cup there, we're back to wrap up the lab. Okay, shows here on the lab, okay, that the data here, the cup was set to be 1 meter away to start, and then we moved the cup, all right? So then we had to calculate the potential energy. We found the mass of the marble, 0.006 kilograms. We multiplied it by how strongly gravity pulls on objects on Earth, and we multiplied it by the height that the ramp was. We did all of that and multiplied those 3 things together, and we got 0.0882 joules. So in the space over here, right, 0.0882 joules. All right, after that, those questions are for you to work on. So best of luck, and we'll see you next time.